Yes, Sanchit, it is.
Awesome. Awesome. Thank you. Thank you so much for that warm welcome. And thank you everyone for joining today's session. We are back with another session today in this entire series or bootcamp of cloud practitioner, right? Today we'll be talking about continue what we have done in the last session, which was more around introduction to Amazon S3, as well as Amazon compute service. We initiated that and we spoke about Amazon EC2 instance, right? Which is a more of foundational service which people generally use whenever they start working on AWS on the cloud. Storage and compute is what they start with. So we have done through a couple of things. Now today's session will continue our journey with Amazon compute services, and we'll look forward a couple of more concepts in it. The advanced one, when you talk about building any solution for enterprise. So we'll continue in the EC2 segment itself. And then we'll move towards other stuff, which is around containerization world, like ECS, EKS, Lambda, as well as application integration. So I think we have a lot to cover in today's session. So let's quickly go through that. And yeah, please, let's make this interactive session. So if you feel you're not if you're not comfortable with the speed, or if you have any doubt, please post in the chat or unmute yourself and let me know. I'll be happy to address that. So to make it more interactive, this session, and also this is for you guys, so you understand it well, right? With that note, let's begin with today's session. I'll quickly go through introduction. My name is Sanchit. I work as a lead architect at Quantify. It's a startup which is in the data analytics company, which we do any workload around data, AI, ML, data warehouse, modernization, DevSecOps. Those are the different skills what we do. And we are a very cloud-centric company. Along with that, I also am APN Ambassador. So really my passion is to work with different user groups across India, outside India, work with them to help them grow, share my knowledge across community, and conduct as different bootcamps, because that's what I love outside helping to understand different services. The second thing which I do frequently is to conduct different bootcamps for certification, which like cloud practitioner, solution architect, or serverless. That's exactly I love to do, because bootcamp is something where people learn in detail rather than in one particular session. So that's what exactly I always look forward in my free time outside when I'm free from my professional job. So today's agenda will be more around, first, we'll quickly recap for the folks who have just joined us today for this session. We'll quickly recap in few slides what we covered in the last session. As I mentioned, we'll continue our journey with Amazon EC2 instance, the advanced concepts to make a highly available solution. Then we'll move towards ECS, EKS, and finally at Lambda side of things. Okay. With that, let's start around the recap. I think quickly I run through the recap slides. We understood what is S3. It's an infinite scaling fundamental service. Any service that you talk about in AWS, either you will see S3 as a part of, as a backbone to store the log files, or some other way S3 in some proportion, some bit of shape. S3 is already used as a part of solution, or you pick up any solutions, whether it's on a platform, DevOps side, you talk about machine learning, you talk about data analytics. S3 is a core component to store the objects, to store the log files, to store the data, because of its nature of highly scalable pay-as-you-go model, and it's very cheap as the total storage increases. Like if you talk about terabytes, petabytes of data, the price per GB is very less. So because of that features or functionalities, S3 is like a very popular services. Along with the storage, you can also do things like notification. So whenever someone uploads the file for any action that happens on S3, in short, someone uploads an object, someone deletes, someone creates a bucket, you can orchestrate or you can capture those different events or notification, and you can do any sorts of business processing, maybe alerting, monitoring, processing the file, like those kinds of stuff. You can easily do it with the event integration and other stuff. And we did a demo also about it. So that's about overview on S3. Then we understood like what are the different storage class we have. The idea, for sure that we have gone through each of this particular stuff. If you want to understand what are this each storage class, how the offering differs, how you want to select, I would request please go through the last, last session's video. It is already there on the User-group Bangladesh YouTube channel, and the link is in our Slack group. In short, this storage class help you to provide economical benefits in terms of pricing as with less compromise of performance if you rightly understand your use case and select the storage class based on use case. Like for example, for archival, you can use Glacier. For like your constant workload, constant kinds of stuff, you can use standard. If you have on and off kind of a pattern, you can use intelligent. Like sometimes you have a peak, sometimes it's low, then you can use intelligent tiering or infrequent access. Those are the different options, different kinds of storage class are provided. And again, this is the way you can store your data in S3 and save much dollars when it comes to the total storage pricing. Then we also understood, let's say for an example, there is a use case that, okay, generally when I upload something, it goes as a viral, but after a few days or after a few months or after a year, I don't even look up that object, but I still want it. So if that kind of, you have like a complex kind of requirement, I need like multiple kind of storage at a given period of time, then you can have something called as S3 Lifecycle, where with the help of that, you can move, you can define your rules, lifecycle rules, and you can move the object. As you can see here on the right side, you can move the objects from one storage class to another based on the rules and your requirement, which will be taken care by automatically by S3 on a defined time period. Like for example, of Jan 1st, you upload a new object and you say after 31st Jan, you move to Glacier. You don't have to remind S3. If you just configure it once, S3 automatically on 31st Jan, end of the day, it will move it to Glacier. So those kinds of intelligent transition can also be done with the help of S3 lifecycle and lifecycle rules. Then we also seen Athena, which like works on a Presto distributed query engine, and it's more like a serverless warehouse kinds of stuff, which is used to do more of analytical processing. If you have any data which is stored in S3, you can just go through Athena and you can query the data, do some analytics around it, as well as you can query the data which is stored across your different other sources, not just limited on the cloud, but even on the on-prem with help of Lambda. So that's about Athena. And then we move towards EC2 instance. We understood how exactly the landscape or the structure is when you talk about virtual server on-prem versus EC2 instance. And we understood in case of EC2 instance on the cloud, this purple slot is already taken care by Amazon, and we are responsible for OS and app. I mean, first from the virtual server, where you select the right configuration, and then you, along with that, you also select the right OS like Linux, Amazon Linux, Windows, Ubuntu, Mac OS, different kinds of offering which is given by Amazon, and as well as you deploy different application for which you're launching an EC2 instance. So this green box is something what end user is responsible, which we also looked a quick demo, how exactly this entire thing works. Even the instance type, we understood that different types of instance are available. As I mentioned in the last lecture also, same I will repeat again, the selection of storage class, the selection of instance type, or any other configuration which you see, you really have to understand the ask, the need of your application. It's not just you can directly select based on the cost or based on the high performance. You have to really understand the core, what kind of application it is, how application is going to perform in the market or the need of it, right? Now, for very example, if you're building some algorithmic, very high processing application, which can be, let's say, some machine learning stuff, right? Now, for that stuff, you cannot have memory optimized. For sure, you will need something compute optimized because you need high processor. Whereas if you're doing some data lake kind of thing, right? Data lake, Elasticsearch, there you need high memory because you need to load that data in memory for processing. So where you will need memory optimized. So this are the very simple example. So you have to really get to the core, what kind of business application you're building, and accordingly you have to select this. Another example can be you're doing some image or video processing. So for that, you will need a GPU instance, graphical instance. Now, if you do the same thing on compute optimized, the performance is not going to be, I mean, it may not even work. And if it does work, the performance is not what you're expecting. So you have to wisely understand this different offering from Amazon in terms of instance type. And then you have to put that across your application requirement and select one of them, which matches better for you. And then we also understood the instance billing model, like how exactly the billing models are there: on demand, spot instance, reserved, and saving plan. Like on demand is something like an kind of a cab where you just say that, okay, I want to just go from place A to place B. You just look into a cab and you order it. Second is like a spot instance, pool cap, sharing cap kind of stuff, where, okay, if place is available, you will get it at cheaper rate. If not, then you have to wait. It might be even possible that you book a pool cab, and if the person gets a ride which is more offering than you, then even he might reject, right? There is no reliability around it. So that's spot. Reserve it is more like you reserve it, you book it for a month or sort of a thing, that, okay, I'm booking you for a fixed period, which in case of Amazon world, it is 1 or 3 years of kind of commitment which you're giving to Amazon. And then you can say, okay, whether I'll pay one time upfront or whether I'll pay like no upfront kind of stuff. Based on that also you get a discount around it. So that's about reserved. And saving plans is more optimized way of using on an hourly basis, right? You can just give a commitment that, okay, hourly basis, I may be consuming $5 per hour, right? So not a big commitment, but still there is a small amount of commitment. And even if you don't use $5 in a given hour, Amazon is going to charge for that. And again, that is also comes up with more of commitment. Again, as you go from left to right, the flexibility, or I'll say the flexibility somewhere decreases, right? Because on demand, you're very flexible. It's on you. Today you have a requirement of launching T2 micro. Tomorrow you may have a requirement to launch GPU instance. So flexibility a bit increases. Not completely small. Negligible it increases, but even the saving of the cost also increases. So what you get in on demand, as maybe let's say getting $5. Similarly, in spot, reserve instance and saving plan will get at a cheaper rate. Okay, for sure, I will go through that. So reserve instance and saving plan. In simple, if I define is reserve instance, you come up and say, I know internet, you would have looked into the internet, look into Amazon documentation first. And reserve instance is something you're telling that, okay, rent, like when you rent a property, okay, very simple. You tell that person, this is the rent is going to be, and this is the year I'm going to rent it. Accordingly, let's say you rent a place for 1 year versus you rent a place for 5 years, for an example. The more period it is, that you can negotiate that deal. You can tell them that, okay, hey, I'm not going to pay you X, I'm going to pay X1, 2, 3 and all. You can negotiate that. And then on top of it, you can also get more discounts. If you tell them that, okay, I'm going to pay you the rent in one go for 5 years, for sure that person will give you more discount on top of it, right? Or I'll pay the rent at the end of the month. Then the discount may not be applicable. That kind of terms and condition you have. That's exact model is reserve instance. That you reserve that particular place for a fixed duration, and then you have an offering, right? This fixed duration is 1 to 3 years, and the flexibility is you cannot leave. You cannot move out from that place. The only thing is you can get someone else and you can exchange. That exchange is possible, but you cannot say that, I'm not interested in your place after 6 months. That flexibility is not there. And options are there that you can give the rent in one go for the duration, which will give you more discounts, or you can go with your monthly cycle, which you may get less discounts compared to upfront. So that's exactly kind of a reserve instance if you read the text here. In case of saving plans, it's more like how we can call as a VWorks, right? In VWorks, that's an hourly model. So you tell VWorks, okay, I need 720 hours of your sharing space, right? Now 720 hours, or you can go more commitment. Now, even if you use 720 hours, still you have to pay for it. Even if you don't use for 720 hours, still you have to pay for it. And you can say 720 hours I will consume in a given period of 1 year, 2 year, 3 year. That's the saving plan around it. So that's kind of saving plans what you have, that, okay, you say, I'm going to use this committed, what I'm committing you, I will use it for given period, within given period of time. Even if I don't use it, I have to pay what I've committed. That is the saving plan. So that comes the different kinds of stuff. So the commitment is lesser in saving plans, what you have in kind of a reserve instance. Hope I think my explanation is clear. And again, the biggest difference that will come up in reserve instance and saving plans will also be, there are different kinds of saving plans also you can do. Saving plans in terms of hourly billing. Like, okay, maybe I will only pay $5. Within that $5, you can spin up T2 micro, GPU instance, M4 large, M5 large, any kind of thing. Or there are compute-based saving plans that are also there where you say that I will only spin up T2 micro for $5. So that kinds of stuff is there. In reserve instance, it's mostly on the specific instance type. Again, you can have more like there are two types of reserve instance are also there, standard and convertible. Standards are much more cheaper. It will provide you more discount compared to convertible. In standard, you say I'll use M5 large for 1 year. This one instance I will use for, let's say, 1 year. So the discount which you will get will be larger. So that's a major difference when it comes to reserve instance and saving plans. Then we also looked into the types of EBS volume like SSD and HDD. We understood it like where exactly SSD will be used or where will HDD be used. Again, you don't need to mug up any of these numeric numbers, not just for cloud practitioners. Even for professional exams I've given it, you don't have to mug up it. This is purely your understanding, as I mentioned in the previous slides also. The whole idea of giving this number is to make you more understand that given a workload, you have to rightly select that services, because if you don't select the right configuration, your performance is not up to the mark. Then AWS can only give you the recommendation, but at the end of the day, you are the decision makers based on your application. So these numbers are more for you to understand, but again, they are not to mug up and you'll get into exams and other stuff. So do remember that. With that, we finish our recap, what we have covered in the last session. Now we'll start with today's sessions, right? So today's session, I'll start around auto scaling. Again, this particular, I'll give a precursor. This particular session, like auto scaling and Lambda, I'll keep it more fundamental and conceptual. There is a very good demo which I do in case of auto scaling and load balancer, which will cover up in, I would say, 4th or 5th session, where you have more broader understanding of VPCs, subnet, and all of the stuff, like the networking part of it, which will cover next after this, but in the next sessions. But before that, you guys will not able to understand the exact demo. So we'll skip the demo from this session and we'll do it in the upcoming weeks. Okay. But yeah, let's understand what exactly is the auto scaling. So far, I think everyone would have understood some terms with always comes up with the cloud is called as elasticity or scalability. You always get why you want to use cloud. Everyone will say it is scalable. For sure, it is pay as you go. It is scalable. But do we really know how it is scalable, or how cloud provides scalability? So exact is the case, which is called as auto scaling. As the name suggests, automatic scaling. So in case of EC2 instance, just assume, for an example, you have built Amazon.in, the e-com website. Now Amazon.in is going to have a sale, right? Some festive sale they are going to offer. It's very difficult that you can predict any kind of people you need. It may be 1 lakh people join, or you get 1 lakh people participating or visiting your page. It may be even 10 lakhs. It may be even like 50 lakhs. Now it's impossible that you can estimate that this may be my number of people and you scale up your instance, right? It may be under, it may be above, it may be below what you have expected, or it may be above what you expected. It can be any side of it. It depends, right? In such scenario, what you do is you automatically scale your infrastructure so that you can serve the request of all the people that visit your website. And how that scaling is done? That scaling is done with help of auto scaling. So in case of auto scaling, there are different conditions which you can define. Conditions such as you scale my infrastructure from 9 a.m. to 5 p.m. Like for example, you're going to release some university results. Now you're pretty sure that university results will be viral for like 5 hours or for 10 hours. Post that, there will be few people, but that will be a very normal traffic. So that kind of condition you can add in your infrastructure, that, okay, from period X to period Y, you increase and add my server from 2 to 20 because the traffic is more for that period. And after that Y period, the traffic will reduce. So you automatically decrease back or scale down to 2. So that kind of intelligent rules you can define in auto scaling. That is more predefined condition that you know this event will occur and you predefinedly add it. Or you can define that, okay, hey, if my CPU utilization goes above 60%, let's say for an example, you're processing some machine learning. Now it is very difficult that you don't know how your model will handle the load, right? Based on the data volume. So you can also define based on CPU that if my CPU goes about 60% as a part of auto scaling policy, you scale the instance, maybe from let's say 5 to you scale it up to 15. And when it is fall back again 60 for a defined period, you scale it down back to 5. Similarly, you can also configure on the network layer. Like if the traffic on the network is X volume above, you scale. So those kinds of intelligent condition you can add in auto scaling. So auto scaling can understand it that, okay, yes, this particular condition has occurred for a fixed duration of, let's say 2 minutes, 5 minutes, what you define as a part of your rule, and it will automatically scale the infrastructure, as well as you define the scale down policy that, okay, if it goes to reverse, let's say if it is back below 60% for 5 minutes, you scale down. So you define scaling up, scale down, both kinds of policies as a part of auto scaling policy. That way your infrastructure dynamically scale down without you manually going and increasing. Again, there are features you can manually grow and do the auto scaling also, but you never know, right? It may be like 2 a.m. in the night, you get a larger audience because some discounts or something starts. Now we cannot just observe that, okay, now the people will come, so I have to add 10 more instance, I have to add 15 more instance. So that's kinds of intelligent rule you can add in auto scaling, which will increase your infrastructure or do it. So before we go through the text, you can see this kind of an image, right? So auto scaling generally is 3 process: what, where, and when. What is like you define what is my configuration. Like configuration is like simple. When we saw in the last lecture about EC2 instance, we will provide the name of EC2 instance. You provide AMI, which is like OS, instance type, like which family it is, the key pair, what kind of application you're running in auto scaling, security group, and IAM role. That is like a configuration you're providing of your server. Then you provide where, what is the location of it. Like location is like, okay, in which region, which availability zone, which load balancer, right? What is the metrics you are, what kind of health check you're doing. So where exactly you're doing. And then you provide when. When is exact the condition which I was explaining you, right? Some predefined condition, some real-time condition based on CPU and CPU memory or network kind of thing. So when you want to do auto scaling. So there you define auto scaling policy, which helps you to define those different conditions to scale up. When you add more instance, it's called as scaling up. When you remove certain instance, that's called as scaling down. So based on that, you define an auto scaling permission and schedule actions. Like schedule action was the same thing. You define a rule that, okay, for this period, I know the traffic is going to increase. So you schedule the action, or you dynamically based on a given property, you define. So there are different ways, like you can have SQS also, like some other services, or you can have the property of your server as an average. If the average CPU goes about 50% of all my servers, you increase. So those kinds of intelligent when condition you provide, and accordingly auto scaling will react. So that way it helps you to achieve 2 things as a part of auto scaling. First, it gives you the scalability, the elasticity. 2, it is cost optimal. Now, any people can tell me, hey, I can just spin up 200 instances. I don't even need auto scaling, right? 200 instances is more than suffice. You're exactly right. But again, you don't know. You're anticipating that you might get like 50 lakhs of users, but you got 5 lakhs of users. Then you don't even need those 200. You can easily survive, or you can serve those 5 lakhs of people with 15 instances. Then you waste your 85 servers, right? So the costs get wasted. So that's exactly the cost saving you get, because based on the real-time traffic or real-time scenario, you are scaling up the servers. And again, we have all, I've also seen when you define the scaling now, you can define end up based on more complex condition. If it is 60, you can have, let's say, 3 more instances to add. If it is 75, add 3 more. If it goes to 90, add 3 more. That kind of stagger kind of thing also approach you can do. So it's not just one single condition, you can have multiple such condition, and that way you can make your entire application more highly available across availability zones based on the given scenario. So that's about auto scaling. I can, as I mentioned, S3 and EC2 instance were the fundamental when you start your cloud journey. Auto scaling as well as the next topic, load balancer, are the fundamental when you start really designing your architecture. Any architecture, whether it's a machine learning training, whether it's a data lake, or whether it's any software application, auto scaling is a core part when it comes to the highly available principle of the cloud. So always do remember, and this is really a good point where you have to go depth outside your practitioner certification. Practitioner, even if you refer this slide and understand, you will be able to answer it. But if you really want to go to the core of the cloud, you have to focus a lot in auto scaling and load balancer. Then next comes is a load balancer. Now, as I mentioned, continue the previous discussion, right? I'm going to scale my number of servers. So with that, it is also important that the traffic which was coming to X number of servers, let's say 5, needs to now go to the 10 server after scaling. So that's exactly load balancer and auto scaling works very closely in hand. Load balancer always is responsible for distributing the traffic in round robin wise by default. So there are different types of load balancer you have, and different way you can even manipulate how load balancer can distribute the traffic. By default, load balancer always distributes the traffic in round robin. That helps you that today, if you have 5 instances, 5 same types of application running in same instance, right? Different instance. If you have tomorrow's 10 different EC2 instances running same application, it becomes very easy without human intervention. It automatically adjusts the distribution logic. So that's how elastic load balancer works in a round robin fashion. The whole idea is to distribute all the traffics that comes to the load balancer that goes to backend server. Very simple, which I gave like an online shopping, right, of Amazon.in. By default, you hit Amazon.in, which you hit a load balancer, and load balancer distribute the traffic to any available server behind it. Maybe 10, 20, 30. It distribute all the traffics around it. Now, there might be requirement that a person needs to only go to X server, not to Y. That additional thing will understand in upcoming server, but by default, it supports in a round robin. So it might be possible that, okay, if there are, let's say, 5 instances behind a load balancer, for the first time when you hit a load balancer, your request may be served by first server 1. Let's say you refresh the page again, and then you hit the load balancer again for that request. It is not necessary that your request will go with the server 1. It will be based on round robins. It may also go to server 2 or maybe server 5. There is, I mean, in terms of load balancer, distributes the traffic in a stateless fashion to the backend server. It will not remember that, okay, Sanchit just visited back 5 minutes, so I need to only transfer his traffic to server 1. No, unless you enable some kind of cookies or session, sticky sessions, then only it will understand. Otherwise, it works in a very stateless manner. So that's what exactly the load balancer. And again, auto scaling scales the number of servers. Load balancer ensures that it distributes the traffic evenly across all the number of servers in a round robin fashion. Do remember these 2 logics, which are very core when you design the architecture. Then comes this different types of widely used load balancer. Technically, there are 4 types of load balancer are there: application, network load balancer, gateway load balancer, and classical load balancer. Generally, widely used are 3 of them. And in that also, the application load balancer and network load balancers are in detail. Classical is almost the very old generation load balancer. You can say the first one before ALB and NLB. Almost NLB and ALB has overtaken classical, but still there are certain applications. Certain monolithic application, they do need classical load balancers. So it's not deprecated or retired. It still do exist. But Amazon suggests that if you can follow widely ALB or NLB, it is really good based on the new stuff, right? Now let's really understand what exactly are this. Each of these load balancer are and how they differ in real world. So as I mentioned, classical load balancer is very simple. It doesn't have any intelligent smartness. Whatever traffic that comes, it will distribute across all the servers in the backend. So let's say if there are 5 millions of users, it will just distribute all the traffics. Very stateless manner. It don't have any kinds of intelligent. When it comes to protocol, I mean, in load balancer, the more important thing is the protocol. It supports all HTTP, HTTPS, TCPs, UDP, those kinds of stuff. It do support. So that's not the problem. It's a very simple way of doing it. With that, this is a new thing that come up with the application load balancer. Now, the biggest difference in as I mentioned, the classical is a very simple. Whatever a request comes, it sends it. Okay. The application load balancer technically works in more like a microservice kinds of fashion. And along with that, there are other smart things that comes along with ALB. First, let's say, for example, we all have, any person from this audience who have worked in like a software background, they would keep hearing something called as microservice. Every API which you design works in a microservice / get / post / put / delete, right? Now, technically, you cannot achieve that kind of microservices path-based, like /path, right? In case of classical. Classical is more like a domain kind of thing. Let's say, for example, you build a CRUD operation, right? Create, retrieve, update, and delete kind of stuff. So that should be create.example.com, retrieve.example.com, delete.example.com. It cannot have like in the path format. But in case of application load balancer, things got changed since it works on OSI level 7. It gives you the path based. Like you can have example.com/create, example.com/retrieve, example.com/delete. The advantage is you don't have to have multiple domains, as well as application in the ALB itself. You can have path based routing or port based. In the path based, it can decide that this can be /create, /retrieve, /delete, or it can be port 80, port 8080, port 443. That kind of intelligent routing it can do based on the rules you can define here, as well as I mentioned, that let's say Sanchit, for the first time, it got traffic from this particular server, which is an ALB1, AZ1, sorry. Next time also, if Sanchit wants to even go to the same server, you can enable something called as sticky sessions. Sticky sessions, that means for the duration of the sessions, I will always route to that given instance. Like if you have something, some specific computation that server is going and you want to constantly check, then you can have that sticky session enabled. By default, user will route to that server only unless that duration expires. So that kind of three intelligent kind of thing the ALB provides on top of the classical stuff, like the routing, the intelligent routing, which is path based or port based, or it also provides sticky sessions. And it supports two kinds of protocols, HTTP and HTTPS with SSL and those kinds of stuff. So the problem that comes with ALB is, let's say if you have any TCP. Now, as I mentioned, it works on layer 7. It supports HTTP and HTTPS. But if you have any TCP requirement, you need any application which works on a TCP. So ALB was not able to support that. So that's why people were widely still using the classical load balancer. With that, Amazon came back with a new load balancer, which works on TCP and UDP traffic, which is called as a network layer. It is called as a network layer also because it works on the OSI layer 4. In that entire segment, 7 layers of OSI model, it works on the 4th layer, which works on the network. So it is network load balancer and it supports two protocols, TCP and UDP. So that gives you the option that, okay, if your application works on HTTP and HTTPS, you go with ALB. If your application works with it needs like TCP requirement, you go with NLB. And that's how Amazon planned to retire classical load balancer. Along with that, NLB also provides things like static IP address. So as I mentioned, right, that load balancer is more like a stateless in nature. But there are certain requirements where you want to whitelist, right? You generally whitelist your IP addresses in case of firewall and all. Now, even if you want to use a load balancer and you want to whitelist it in your, let's say in your company network load balancer is the right choice because network load balancer provides a static IP. And that static IP you can use as a part of your whitelisting process. Mostly, if you talk about the entire ECS and ECS fundamental, like the container part of it, people uses ALB or NLB based on the kind of applications you have. Mostly, if you host any microservices or any web applications, people generally use ALB because of the path-based routing. So network load balancer doesn't have path-based, but it is widely used when you have more of like internal communications. internal communications in terms of, let's say, private communications from one server to another server also. So there is a kind of a design pattern. I mean, that's completely out of the certification track, but anyone who has some knowledge, or when you start designing the complex, right? Generally in the market, people uses ALB and NLB together. So I'll also cover that advanced thing at the last, but there is a pattern where people use both of this load balancer together to design more highly scalable from a network perspective, as well as the path-based routing capability of your entire application. So those two things also works in collaboration together. So do remember that it's not that you can only use one load balancer. ALB and NLB can work together. But with that, there are a couple of people who also come into it that, okay, hey, I have a firewall, right? I mean, generally people do use an external firewalls, Fortinet and those kinds of external firewalls. How I can scale to that application? Now you said you have HTTP and HTTPS, you can go to ALB. You have TCP and UDP, you can go to NLB. But this firewalls is more like a, I wouldn't say validation kind of thing. Like any traffic that goes, they need to validate it. They need to reroute it through the firewall appliances. How that can be taken care. So to address that requirement, Amazon came up with the gateway load balancer. So gateway load balancer is mostly used for third-party virtual network appliances, such as firewalls. Generally, what people do, right? Any network packet that comes into your network, they want to inspect it. Or any network packet that is moving out of a network, they want to inspect it. In that kind of requirement, how you can scale your virtual appliances, like the virtual firewall or IDS or any preventive system. There, for those appliances, you can use gateway load balancer. This is not meant for like your normal, let's say, front-end web application. For that, you can use ALB and NLB. This is for more like a security scaling kind of stuff for virtual appliances. So that's how Amazon provides 4 different types of load balancer. Classical load balancer, application load balancer, network load balancer, and gateway load balancer. And here comes one slide which will help you a comparison across when you should use what type of load balancer and what are the features and functions provided. This exactly covers what I have mentioned, each of this stuff, right? And ALB works on layer 7, layer 4, layer 3, classical works on layer 7 and 4 both. These are the protocols it supports, which we have spoken about. Static IP case. As I mentioned, only network load balancer supports static IP. None of the other load balancers support. So if you, I mean, ever in your real architecture scenario, if you see that there is a requirement of static IP address, by default, you can select NLB as of today. As of today, none of the other load balancers support static IP, right? That's more like a chip trick or shortcut, what we can say. Then you have SSL offloading kind of stuff. Other requirements are also there, like end-to-end encryption, sticky sessions, path routing. Path routing is that I mentioned, right? If you have example.com/create/update/delete, as I mentioned, only ALB can support. That is why any microservice application or any web application you will see, 99% of the people uses ALB on top of ECS. They might be using NLB, then ALB, then ECS, but technically ELB will be sitting on ECS to achieve that microservice design pattern. Then there are other kind of stuff you have, like cross-zone load balancing, the type of backend what you can have behind the load balancer. Like you can have EC2 instance, you can have Lambda, you can have an IP address, those different kinds of stuff, and the use case. As I mentioned, ALB is widely used for website and web application. This is used for application requires low latency. This is used for any sorts of security, third-party virtual appliances, and this again used for generally web application as well as the low latency part of it. Mostly people try to avoid classical load balancer now, unless you don't fit in the first 2 columns. But mostly these other 2 application load balancer widely used. So that's about load balancer. The 4 different types of load balancer, the comparison across all the load balancers. Here we end the EC2 segment around it, right? Which falls under compute, processing layer, compute services, compute segment. We finished the EC2 instance. Starting from, we understood what is EC2, what are the type of EC2 instance provided, the difference pricing, the type of volume, auto scaling, load balancer, that covers most of the part. Now we will see ECS and EKS generally are it's a new offering in compute, but underneath of ECS and EKS is widely used EC2 instance itself. So now it will be very easy for you to match the different things what we have learned so far, the different types of, the auto scaling functionality, the way to launch the EC2 instance, the instance type, that remains all common across ECS and EKS. You can just say this is an over and above of EC2 instance if I put it out in a very layman language. First, let's understand where exactly virtual servers, virtual machines more you can think of an EC2 instance versus container. Like technically why you need container or where exactly container can help you. So far we understood that EC2 instance is good. You can have, first of all, most of the section is taken care by the cloud vendor. And then top of it, you have the entire thing of server selection. And then you have the entire OS. So if I talk about what I'm mentioning, if we go in this slide, right? This purple section was taken care by the cloud and you're only responsible for the server and app. But still, what people saw in the market is that there are many users still not widely using this entire section. Like, okay, with help of virtualization, you are fully utilizing your hardware thing. But still, there is a scope that on the OS level and the app level also, you can segment a bit more and you can properly use to the extreme level. There exactly they come up with the logic of containerization. So now if you see, there is a physical server you have, then you have the OS operating system, then you have a Docker engine, and on top of that, you have the entire container. So previously in the virtual server, the guest OS was tightly coupled in each of the VMs. Now what got changed is this guest OS become a common as a host OS. So that reduce the entire maximum of the size of image, right? Now, anyone who has installed any sorts of Windows OS, right? Windows, Linux, you would see by default that image is mostly more than a GB, like bare minimum, I would say. Now, I don't even know, like this Windows 12 and other stuff will be more than even like 2-3 GB gigs easily. But by default, it's of 2 GB or 3 GB. The Linux or Ubuntu will be somewhere around like 700 MB or 800 MB. Because the major component is the guest OS. Whereas if anyone really have seen the Docker, if not, then you can go to the Docker Hub. You can Google Docker Hub. Any Docker image will be at max of like few MBs, very few MBs. If you rightly, if you have rightly build your image, it won't be more than like 5 MB, right? Why there is a big difference on it? End of the day, both provides the applications. What's the difference? The difference is in case of Docker, what they have done, the entire common thing across entire containers, they have moved as a part of your node itself, Docker node. So which talks about Docker engine, which talks about operating system, which talks about the entire support or entire middleware they need. They put it out in the node, and the only core thing which you need as an end user or as a developer is your application and the supportive libraries. So your 5 MB Docker image only holds either your code or your library. Whereas in case of your entire virtual machine, it holds everything, not only just your libraries and application, it also holds the OS. OS can be like Windows, Linux, or Ubuntu. That's why it is of gigs and it's of MB. Again, now someone will say, okay, so what's the problem there? If it holds, right? What is the problem? The problem is the time it takes to launch a new server. Now, as I mentioned, auto scaling, right? In case of auto scaling, when you deploy auto scaling, the thing is that, okay, there will be certain people, there are certain people. Now you cannot tell people, right? Hey, you just wait in a queue. My infrastructure is getting ready. You need to not only just have the capability to increase your infrastructure, but you also need a capability to fast increase your infrastructure. That less than half a minute, the infrastructure should be in that healthy mode. There you will see containers are widely used because of the capability. The low weight application package that comes compared to EC2 instance. That is one of the reasons why most of the modern era applications which are currently built are built on Docker. Docker, when I say widely built on ECS and EKS, because of that nature. Because end of the day, when you auto scale it, you scale two ways. Either you auto scale on the node level, which is EC2 instance, or you auto scale on the application. But that's how you're only scaling the things which you need, not the entire baggage of guest OS and all. That's exactly the difference comes in the VMs and the containers. And please, I know this is very complex concept. So if you have any questions, please post in the chat. Now, taking that knowledge ahead of more of providing the container-based world, Amazon provides two services in that world. One is called Docker, which is like an ECS. Amazon is the only cloud which provides ECS, container service. Okay, there are other clouds which also provides EKS. Even Amazon do provides Kubernetes, but Amazon is the only service which provides ECS, which is the Elastic Container Service. Elastic Container Service is exact what we have understood, right? If someone wants to have like a application kind of stuff, then they can use this ECS, and there are different other things up in there. But if you look into the architecture, right, first, this is your EC2 instance. And within an EC2 instance, you define a different task. Now, task is nothing but your Docker application. If you talk about simple, it's your Docker application, right? In a very simple language. So this is like a auto scaling nodes, what you have spin up, and each node you can have multiple different Docker application, the containerized application. Okay, and then on top of it, you can have the same load balancer. Like here, you have the load balancer. You can have the volume, the cloud watch for monitoring. Those all remains the same as I mentioned in case of EC2 instance. So here also, as I mentioned before starting container, your core of EC2 will remain the same. It's not going anywhere. It's just that people have more optimized the way of leveraging EC2 instance. Okay, so this becomes your EC2 instance, ECS. Now, some people will also say, you said ECS is there, EKS is there, why to use it, when to use it, what is the difference? We'll cover in the upcoming slides. But for now, there are a couple of concepts which you need to just remember when you talk about the ECS engine. Again, when it comes to the cloud practitioner from a certification perspective, you just have to understand what is the containerization, what offering AWS provides. You really need to, you don't have to go down to detailed of task, what is a task, what is services, what is cluster, scheduler, and state engine. But again, I just want to be sure that when I'm covering a particular topic for you guys, you have some broader understanding rather than just, okay, there is a container service. Okay, I have an ECS without any understanding how exactly that ECS works internally. Okay. So first is the state engine. State engine is more like, if you see here, there's a complex management that needs to be done. Management in terms of, I have 3 nodes, one EC2 node, 2, 3. Now there has to be a slots. I cannot randomly put the task in each of the EC2 instance. I have to smartly deploy in such a way that it is also been optimal use across the server. So that state information, that which cluster holds what kind of task, in which cluster I should deploy the task, those kinds of state information is handled by the state engine. So as I mentioned, state engine is designed to keep track of available host. Host, you mean the EC2 instance, the running containers, which means the task, and other functions of the cluster management, which includes things like communication or the deployment part of it. So this becomes a very core internal database of ECS to track what's going on across the different EC2 instance. Scheduler. Scheduler is like more kind of stuff, a more important functionality when you want to deploy. So what scheduler works closely with state engine. So state engine tells scheduler, hey scheduler, in node 2, there is 1 slot. So you can deploy task 3 under node 2. So scheduler then will go and deploy that. So similarly, you can also think of that scheduler first approach state engine. Tell me where I can deploy this node or this task or this Docker container application. Then state engine mention go and deploy to server 2, and it will go and deploy. The cluster is simple as you can think of, very simple is EC2 instance. Deploy across different availability zones. Task is more exact, simple ways. The task is like a unit of work, like which can be anything. Task in simple can be deploy Nginx, run a Python code, run a Java code. That's exactly is a task which you want to do within a container, and you define that in a JSON format. So this task is this particular white box, right? Which is within the container, you run anything. And the last is the service. Service is like this component specify how many same tasks. So if you understand, I mentioned there are two kinds of auto scaling which you have. In case of ECS and EKS, one becomes the auto scaling of your application. Now, what I mean, and second is the application of your infrastructure. Let's understand this difference because the same will be in EKS also. First, auto scaling of your application. That means the replica. The right word will be for that will be replica is the same copy of your application. Or let's say you have a Python program or a Java program. The same program you want to run 5 times and a 5 different as a 5 different task. So that becomes your replica that you want this application should be available as a 5 different type. I mean, at a 5 different. Whereas auto scaling, the EC2 one, where you want 5 different EC2 instances are running in parallel. So do remember, service is for the containerized application where you say that, okay, this example, this particular container application, maybe Python or Nginx or anything, should be running 5 count. So that means task 1, task 1, task 1, task 1, and task 1. So that way it will be the 5 count that you define in services. Hope this exactly talks about the ECS. Now, there are a couple of challenges on ECS also. As I mentioned, this is more like a very simple container service provider. But if any complex application that comes where you want to do more other intelligent, more complex orchestration, then how you can take care of that stuff? There exactly comes as an EKS. Now, I mean, any cloud vendor which is there in the market as of today, public, private, do provides Kubernetes as a service. For your knowledge, even you can deploy Kubernetes as an, I mean, Kubernetes is technically an open source. You can also deploy across cluster of EC2 instance. If you don't want to use, let's say, EKS, you can also deploy EKS, I mean, container, I mean, Kubernetes, not EKS. You can deploy Kubernetes on cluster of EC2 instance. I will explain you why you should use Amazon AWS EKS and not the technical open source version of it, right? Again, there's nothing specific to open source, but what advantage EKS can provide compared to that. So as I mentioned, EKS is more kind of a managed offering which Amazon provides, right? Where you really don't have to worry about the installation part of this, like the complex thing. So if you see this architecture, if I just break it down or segregate this architecture, in case of ECS, you saw that is only, there is nothing called as master. Everything is like remain to this 3 servers itself, right? This is your cluster and where it takes care of it. In case of EKS, there are 2 kinds of nodes are there. One is a control plane. One is the entire worker node. So control plane is more like a master node that has the core brain. Whatever the core brain will say, the worker node can be do. Similar, if I put it in a very simple term, is master slave. There is a master and there is a slave. Master is a brain. Master will tell you, slave has to do the work in the same fashion what master says, right? And master will check whether my slave is alive or not. Same is the concept exactly. If I put in a very simple language of EKS, EKS has something called control plane, which is your master, and then it is a worker node. Technically, worker node is the same auto scaling EC2 instance where you have certain library installed to communicate with the control plane. That's about EKS. Now I'll move to the next slide and we'll talk very detailed what exactly and how it looks. But again, as I mentioned at the beginning of this slide, you can also deploy Kubernetes in cluster of EC2 instance. You can use EKS, which is provided by Amazon. So what's the difference, right? The difference here is this master node. Now, technically, as I mentioned, in your entire body, your brain is very critical. If something goes wrong with your brain, your entire body is dead, right? Because that is what it gives you to help you to function your body, that you need to move your hand, you need to move your left hand, right hand, that kind of entire controlling is done by your brain. Similarly, in case of EKS also, the entire control, the master control is done by the control plane. Now, if something goes wrong with your control plane, your entire cluster will get destroyed. You will lose that kind of stuff, right? This is a main thing which simplifies by Amazon EKS. Amazon EKS provide this control plane as a managed offering. Managed offering is that you don't have to auto scale it. Neither you have to worry about the availability. it will be highly available, and everything is taken care by Amazon itself when it comes to detecting and replacing the unhealthy. Let's say if still something goes wrong in your control plane, Amazon will take care of ensuring that your application works fine, and they replace it behind the scene automatically. So your almost 50% of your headache is down. You don't have to worry about it. You only just have to worry about, you only have to worry about this particular section, which is the worker node. That also gets simplified because you have auto scaling and easy to back by auto scaling. So that's how Amazon simplifies the entire Kubernetes concept by providing Amazon EKS, where they take out the entire overhead from you guys and allows you to only focus on your application and leverage the power of Kubernetes. That's why mostly people do suggest, if you really build, I mean, from a POC perspective and understanding perspective, for sure you should deploy auto scaling there. But again, in case of if you already have something like a very complex enterprise kinds of an application, you should always go with Amazon EKS. Now let's understand exactly in detail. If I break it down, that what exactly, I mean, what is control plane versus what you have in case of a worker node, like library perspective, how they are communicating. So this is a very zoom in view. Now, if this box at the top one is called as a master node or your control plane, this bottom one is the worker node, as you can see from the diagram itself. And this is your kubectl. Now let's understand each point at a time. So technically, master nodes is a multi-AZ kind of setup, like highly available. So this is the same replica. What you have, etcd API server. So if you go back, etcd, I mean, again, I don't want to teach Kubernetes, but if someone is very good with Kubernetes, or if you want to really understand in one liner, etcd is more like, if I go back in ECS, there was something called a state engine, right? The state engine used to track the entire stuff. In case of Kubernetes, that is more like your ECD, which is stored in a key value format, the state information. The name differs here, but the functionality is somewhere exactly similar. That if I want to store the information that what are my worker nodes, which worker node should deploy what application, that information is coming here in the form of key value. Then you have the entire API server. API server is any sorts of communication that you want to do. Communication in terms of your entire command line interface with the end user, or communication internal, that has been taken care by the API server. So that is very simple. There are other things that there like scheduler and those kinds of stuff, which you saw in ECS also. Technically, those things are also there as a part of control plane. So that's what I mentioned. If anyone who's very good with Kubernetes or who's doing some Kubernetes certification, they for sure will understand there are many more such applications. But just from a very high level understanding perspective, there are two things. One is to store state information. Second is the API to communicate with the command line and with the worker node. And in case of worker node, there is Cubelet and Proxy. Proxy is more from a networking perspective to interact with your load balancer and other stuff. Cubelet is the core. So any communication that happens is more like with the Cubelet. So Cubelet do ensure all the operational within the worker node. So I will say who's the master, who's the brain of this worker node. In short, this is Cubelet. So Cubelet is responsible. Let's say, for example, you deploy a Nginx image. That image needs 512 MB. So Cubelet is responsible for deploying that image here in this machine, as well as providing 512 from this worker node to that machine. So that's how the brain of this worker node is somewhere is a Cubelet. And then you have this network interface card for communication and those kinds of stuff. So that's how the zoom in view of entire EKS looks like when it comes to the master, which is a control plane, and the worker node. And then there are technically in case of EKS, there are two kinds of command line which is provided. So kubectl is more like, you can say, Kubernetes command line control, right? Where via which you can communicate. You can communicate, you can deploy your application, you can scale up your application, scale down, all those kinds of maintenance and operational deployment work you can do. Amazon also provide there is another offering also Amazon provides, right? Specifically for in case of EKS. Generally, people do use kubectl itself because that is, I mean, in case of kubectl, that's more you can use the open source as well as the Amazon version for it. But if you are a kind of a guy that, okay, no, I just want to very focus on Amazon EKS, that library is called as EKSCTL. The one which Amazon provides is called as EKSCTL. That's exactly works in a similar fashion. Similar commands which you can run in kubectl, you can also run in EKSCTL. So that's about how exactly Amazon EKS works. A bit of high level difference also compared to ECS and a zoom in view from a cluster perspective. Again, please don't get overwhelmed that, okay, too many information. If you have any doubts, any queries, please post in the chat. I will help you. And again, this is not required from cloud practitioner certification perspective, but I want to make you guys understand that how exactly on a high level, this all technology works behind the scene or underneath the hood. Now, someone will ask me that, okay, hey, I understood ECS, I understood EKS. Tell me how exactly they both differ. So here exactly the table it is, right? That when you should use ECS, when you should use EKS, and what kinds of stuff around it. So in case of EC, as I mentioned, ECS is more proprietary to Amazon, and technically Amazon is the only cloud which provides vanilla Docker as a service. When I say vanilla Docker, is more like it's a plain Docker which they have optimized it for their internal as a form of their service. EKS is more like an open source. You can deploy all the cloud in the public and private space to provide Kubernetes as a service, as well as you can also deploy Kubernetes on cluster of VM servers. If you remember, in case of ECS, we use a term called as task. A task get deployed in an EC2 instance. In case of EKS, it is called as a pod. Technically, I mean, if I put it in a very simple language, it's almost the same. But again, you cannot use task when you talk about EKS, or you cannot use pod when you talk about ECS in terms of the proper alignment. Deployment effort perspective, it is very easy. In case of Amazon, ECS, it's very easy because you only have to provide your entire task in form of a JSON. And I mean, for sure, you have to provide a Docker container, your Docker image and all, but it's very easy. But in case of EKS, is a slight complex compared to ECS, because here, as I said, right, EKS gives you more also capability to control the networking part of it, like things like which pod should communicate to which other pod, what kind of traffic should enter, what kind of traffic should live. Those kinds of complex things networking layer also provides. Now, again, if you are given some flexibility, the things also needs to be a bit complex, right? In terms of effort, you just need to not only need to provide the state of it, but also the networking part. From a security perspective, ECS, as I mentioned, is very native offering from Amazon. So they comes with like IAM role and all. In case of Amazon EKS, you have to select, I mean, there are other binaries available in the EKS ecosystem itself, but you have to configure as an add-on. But again, I'll tell you my experience. IAM role is very good, no doubt, from an ECS space perspective, but EKS add-on libraries are very secured, as I mentioned, in terms of SSL offloading, in terms of more communication, access control, or even scanning of it, right? I mean, now ECR do supports it, but again, it's more secured in around it. ENI support is more like a per task level, per pod level. I think that we can skip. It's one and the same. Limits are also fine. 120, 750. I think I've never seen someone deploying on one VM 120 containers. That's fine. Cost perspective, that's very important. Again, if you understand the entire layout of the ECS, you only have the group of EC2 instance. There is no master slave, right? So there is no additional master cost you are paying for it. You're only paying for the cluster of EC2 instance. In case of EKS, you're not only paying for the resources, what you have. Resources, I mean the cluster of EC2 instance. You're also paying for the cost of the master. So that $75, again, this would have revised based on how popular it get, the cost get reduced, but you also have to pay the cost for the masters, in short. So you're not only paying the cost for EC2 instance, you're also paying the cost of the master. And multi-cloud integration, no, it's AWS specific. As I mentioned at the beginning also, Kubernetes is public-private cloud integration you can easily do. Again, one more line item outside your certification. ECS and EKS, even though this is mentioned multi-cloud, integration is AWS specific, but when it comes to the infrastructure, the deployment part, it is not just limited to AWS anymore. There is something called as ECS anywhere, EKS anywhere. You can also deploy your ECS, EKS even on-prem. So it's not just you can only deploy an EC2 instance, you can also deploy on your VM, on your on-prem servers also with help of ECS anywhere and EKS anywhere. So that's about what we have understood about ECS, EKS, how exactly they complement the standard offering provided by EC2 instance and take it to the next level in terms of optimizing, true optimization of the space of, all the virtual servers, as well as what's the difference between ECS, EKS, and how exactly they provides the different offers. Now let's move to the Lambda, right? Again, Lambda, I don't have to introduce it. Everyone would have knowing about Lambda, the serverless, right? In that stuff. Now, many people will ask me that, okay, hey, it's a serverless, then why have you included in this serverless in case of compute? Technically, you guys are right. This is serverless in nature. That's correct. But end of the day, this also provides you the compute platform, the processing capability in a serverless form. So it is also kind of a compute service, which is more like a serverless in fashion. So now let's understand what exactly is, first of all, serverless. It will be very easy for you guys to understand this slide because we have already spoken like 2 hours, like couple of hours in the last session, as well as couple of hours in this session, right? To understand what is serverless. So far, I think we have understood a lot thing that you need to auto scale the server. You need to do a patching of the server. You need to really observe how the application look like. Now, if I tell you, you don't have to do anything of that kind of stuff. Just focus writing your application. AWS will take care of it. Auto scaling, patching, even the cost perspective, it's pay as you go model. How much time your this particular container will be running, you have to pay for that. For sure, you will take for it, right? You will really love it. That's exactly what you're looking around, right? That offering is provided in form of a serverless. That serverless is exactly removing or cutting it down the entire or minimizing the entire operational part of it, like scaling up the application or patching the application and those kinds of stuff. Where you can use like for short running stateless application, event driven application, scales up, scales down automatically, and charges a pay as you go model. So same, I think this last 2 points, if you talk about, right, this is the same, that which and end is exactly the same, but do remember that this application of serverless is not meant for every next application. Otherwise, people won't even use EC2, ECS, and EKS, right? There is certain limitation of serverless, which you will learn in upcoming slides. But for now, you just remember, for serverless is meant for short-running, stateless computation, and event-driven applications. If you have one of these 2 types of requirement, then mostly people use serverless. It's not just for which and end. Those are the last. The most important thing is short running and stateless computation. If you have this one, your application falls into these 2 buckets, then it makes sense to use serverless. And then you get additional benefits of it: greater agility, less overhead, better focus, increased scale, more flexibility, and faster time to market. I think all these points, it's very easy for you now to understand after going through auto scaling, ECS, and EKS in the same lecture. That I'm not even talking about anything auto scaling. I'm not even talking about that you need to configure the right policy in auto scaling. I'm not even talking about using the right server type. I'm just only telling you have to be sure that you have one of these 2 application requirement, and that's it. And that's how you're getting all the advantage. Now you're not worrying about any infrastructure, any right instance type, any right volume kind of thing, right? EBS and all. You just have to write your application. Your application should work. It's a short living, stateless, and that's it. You can easily go to the market flexible. It's very flexible in nature. It will automatically scale up, scale down, and it will also provide you better focus because you only have to focus on your application. So that's exactly what serverless provides. Now, continuing our discussions from where we left around VMs, on-prem, VMs, and containers. Why serverless is more attractive? Okay. One, as I mentioned, it minimizes the operational things, what is there, right? If you go a bit down to the time to provision. So you remember this point I even mentioned in case of containers, that when we started the containers, VM comes with the guest OS as a part of it. So it's very heavyweight package. Docker again is application, so it's lightweight heavy. In case of serverless, it's just only application. You don't even have any other libraries or stuff. It's only your pure application and your pip libraries or your Java Maven, right? So serverless is much more faster to time to provision in that case. The utilization perspective, it's go almost highest compared to container, because again, as I mentioned, container also runs on bare EC2 instance itself. Like it's exactly the same. You're more optimizing or leveraging the best of EC2 instance. But again, when it comes to optimizing in terms of the cost, like, okay, for example, no, you build an application which is only going to work from 8 a.m. to 8 p.m. After 8 p.m. to 8 a.m., no one is going to use it. Still, you need to have that application running. In case of serverless, that's not the case. It's not about that particular block of window. Even let's say for 5-10 minutes, if no one is using that particular application, you don't have to pay the cost for it. So the utilization is highest compared to container. And the charging perspective also, generally VMs are not hourly based. Hourly based people see it's again on the per seconds level itself. Containers are minute, and serverless from a pricing perspective, it falls on the same line itself. But as I mentioned, they are there for that particular period time. So let's say if I have a Lambda, which is used for 2 minutes. So you're only paying for the cost of 2 minutes. In case of containers and VM, the downfall is you have to not just pay on the hourly basis, but you have to have this application running, because you never know when a new user will come up. So that's why the cost is on hourly. People can generally think like in a very layman language, but the cost is on the second levels. Like how second levels, like for an example, you spin up an EC2 instance at 3 p.m. You terminate the EC2 instance at 3:10 for some reason. The charge you are going to pay is for 10 minutes, not hourly. But if you keep running it, generally people do compare it, since it needs to be there available 24/7. That is why that perception comes into the place. So that is why, since it minimizes the operational overhead, so it provides better utilization and cheaper, people use serverless, very attractive. That you just have to focus on your code, no need to worry about the VM servers. That's exactly the whole, I would say, underlying story where people always say serverless is go to the stuff, serverless is this, serverless is that kind of stuff. Again, there are many other people, they have a perspective. Serverless is cost draining, like it more charges you. We will also address those kinds of questions and queries in upcoming slides around it. But for now, we'll go on the positive side of it. Now, this exactly, I think this is a very good slide for you at the right time to understand, right? Since we are already talking about all these compute services, we started with the bare metal in the last sections, where you get complete flexibility, but it is very complex in terms of the cost, in terms of the installation and operational overhead. The flexibility is more around, I mean, you can do anything in that server. It's on your own proprietary server kind of stuff. EC2 is flexible, but again, there are certain restrictions. The restriction can be more, let's say, hard disk, external hard disk. You want to change that, you cannot do it, right? It's a virtualization. Anything above virtualization, you can do in EC2 instance. But it gives you better cost saving. You don't have to worry about setting up the network and everything. You just select the right server, and in a few clicks, you have it. So that's the advantage part. ECS, EKS, we just understood where exactly those two services stand and how they are on top of EC2 as a bare. I mean, EC2 is more like a worker, and how they optimize it above and beyond EC2 instance and provide more control, more optimization. And in true sense, Lambda is a winner here, because it's over completely above. It not only gives you the flexibility to more cost, I mean, better optimization and cost saving, but also, I mean, the downfall is the less flexibility. The flexibility can be, let's say in case of EC2 instance, you said that, okay, I need to set up a Mac OS. That's possible. You can do Mac OS also. Or you say, I want to set up a Kubernetes OS. You can do that. In Lambda, you cannot. Lambda by default is more like you don't worry about the infrastructure. So similarly, you don't get the flexibility of infrastructure. You only worry on your application and provide the right memory requirement for that application. So that's why flexibility is less, but the advantage part, the big advantages are the cost saving, lesser operational overhead on there, and better utilization. So that's exactly where serverless stands if I talk about the entire compute services. Now, this is a very big detail how exactly Lambda works in real life, right? So in real life scenario, Lambda is more either event programming model or function as a service. Like you write one function you deploy in Lambda, and that function will invoke on any action. If there is an action, and that action will be, if you map that action to Lambda, then Lambda will perform. That action can be from anywhere. That action can be in form of the external request from end user. That action can be within the state change in Amazon services, or that action can be any schedule alarm kind of thing. If it is, there is any action, any event that goes to the Lambda where you write your entire function in any of this programming language, and it performs any operation. The operation is not just limited to the AWS cloud. It can also be on your on-prem. Very simple of it. One of the example I've seen recently is, there was one of the use case where I've seen is you upload a file on S3. When someone uploads a file in S3, I want to read that file, validate that file, and put it back into the on-prem database. There was some requirement. Generally, people don't do that backfill kind of thing, but there was a requirement. So there exactly what you can do is, first, whenever someone uploads a file into S3, as we saw in the S3, there is something called as action, event notification, right? In the today's recap section, we understood. In event notification, you can track to Lambda that, okay, this particular file type, like when I say TXT, CSV, JPEG, PNG, this particular prefix as a folder, you trigger this particular Lambda. And then in that Lambda, you write different codes like in Python, Java, and those things. And in that, you can define any sorts of database where you have the connectivity, and that file can be written to that database. So that's exactly how it works. So the question is it possible to launch website without EC2 only by Lambda? Yep, very good question. Technically, you can launch a website without EC2 without even Lambda. So if you saw one demonstration which I've done in the last slide, which was on S3. So yes, you can deploy it as your website as an S3, as well as you can deploy it on Lambda too. So Lambda is the best form of writing microservices, APIs, and those kinds of stuff. So as you mentioned, the load balance and those kinds of stuff, you can have your entire website in a form of, like, say, Node.js or something. You can deploy it and you can do it. Generally, how people works in real life, right? If they want to build a very pure serverless. So if I break it down, there is a front end and there is a back end. They store the front end in S3, which is again form of like a serverless kind of thing. An entire API backend in Lambda. This way they achieve the same use case, what they do in EC2 instance. So that's exactly how they do achieve the website in a serverless form. The front end always remains on S3. So anytime any event comes up, they easily get the front end, and when they do any action, the Lambda gets hit and Lambda performs the required in forms of API. So as I was saying, any state change in Amazon services, any external request via API gateway, or any schedule alerts, alarm kind of thing, Lambda performs the action, and that action can be across anything. It can be also delete a resource, spin up a new resource, write it to database, any kinds of action you can do with help of programming capability which Lambda offers. So that's about serverless Lambda, right? This comes my very favorite important slides. So most of the people you saw when you do different blogs or community, there are two kinds of people which you always talk about. One, who praises or promotes serverless. Two, who always says serverless is not a good service. Again, that's a perspective on it, but my perspective or my take is very clear. Serverless is good if you use it in the right way. Again, if you use it in the wrong use case, for sure, it's not meant of it. So again, the same lines comes at what we mentioned in case of S3 and EC2. What kind of application you have, cloud provides and gives you all the features and functionalities best from a customer perspective. But as a customer, you also have to be very intelligent that given from all the offerings, what is the maximum or the best ideal service for your use case. So now technically, let's say if you do any sorts of data lake, let's say you have terabytes of data and you start processing the terabytes of data in Lambda. And if you come up and say that, okay, no, my Lambda is not working as expected, then you didn't choose the right use case. Because as I mentioned at the beginning of the slide itself, Lambda is meant for short-lived application. Short-lived is like very seconds, like it provides, technically it provides 15 minutes kinds of stuff, right? But I would say, if you have any application which is only for a few minutes, like 2 to 3 minutes, Lambda is the best thing of it. Again, I mean, 15 minutes also, it makes sense, you can deploy, but truly in case of Lambda should be very short-lived application. And again, stateless. Stateless is if you have one request, second request, there should not be any dependency between two requests. It will be very processed in a stateless fashion. If you have that kind of requirement, Lambda is very good to go. The simple example can be the CURD operation. It's pure stateless. You fire a query of create, you fire a query of update, delete, and insert. There is no dependency across all these four. And it should, I mean, technically it will take like 2 to 3 minutes to update a record in database, to retrieve the record, to delete, or to update. For that, it is exact the same use case, right? So it's very important that if you have any microservice, mobile backend, again, the APIs or chatbot, IoT, very specific, again, I'll say IoT, not for data processing, IoT in terms of data or messaging kind of stuff, right? Streaming again from messaging or service integrations. Then serverless or Lambda is exact the right thing around. We will also understand what is server integration, service integration in upcoming slides, but it's again the best thing. If you're planning to host, I mean, I haven't seen anyone doing that, but again, if you're hosting any sorts of database on serverless, deep learning, heavy duty application, some algorithmic, complex algorithmic or video streaming kind of application serverless, it's not going to work. It's not going to charge you extremely, and it's not even give you the right results. You'll not able to solve the problem what you're looking for. So do remember, again, the same lines. There are more services provided by AWS for different use cases. You have to select the right service for your requirement. There, we finished our entire understanding of compute. Amazon S3 we finished compute. Now we will be focusing on application integration. So application integrations is more like the supportive services, which are very core. It's not just supportive, but they are very core services and widely used when you're designing the architectures. Any kind of architecture, whether it's the architecture based on EC2 instance, the architecture based on Lambda, or any kinds of application based on your building, all three services are very good to have. We'll understand each of the services in now upcoming slides. Starting with SQS. So SQS is more like your queuing service. Technically, as you think of here, right? This is the best example. So you remember I mentioned in the auto scaling that you can define the scaling policies. Now, again, the same thing. There might be certain requirements where people wants to process 1 million messages in one go. You will think, are you crazy? How that's possible? Or the other perspective can be, I will spin up 100 EC2 instances and just process it. Okay, makes sense. I mean, both perspectives are right. But if I tell you I want to process 100 millions of messages with 10 EC2 instances only, neither you can scale up nor you can scale down. Also, you need to ensure all 100 millions of users, 100 millions of messages, 10 millions of messages should get processed. There exactly you can use SQS. SQS will more like a buffer. It will keep hearing all the processes, all the messages, and keep putting it into a queue. As and when the consumer can be anything. The consumer can be Lambda. The consumer can be another SNS, or the consumer can be a EC2 instance, right? Which keeps reading the message from this queue, process it, and take an action. Once the processing is done, then the message get deleted. So this way, even if you have 10 EC2 instance and 10 millions of messages, you will successfully able to finish. Again, the time will differ, all these things will come into the place. But if you don't worry about the time and all those kinds of stuff, still in a very low cost, low manner, you can process it. And technically speaking, it's not about the cost. Generally, SQS is a very good service you should add in any high skill processing, because it provides two advantages. One is not only it holds the extreme high end flow, also it gives you error handling. Now someone will say, how are you talking about error handling here? Error handling is, as I mentioned, if a consumer is successfully able to process the message, then it will delete the message. Let's say for an example, the processor, this consumer got deleted. May any reason, someone incidentally deleted it, or it got damaged, or anything went wrong. Then in that case, this message will not get deleted from the SQS. It will go back again the queue and it will be pulled by another new consumer without writing any extreme, not even an additional one single line of code for it. So that's how you can also achieve error handling in your application and ensure that whatever messages are there in SQS are all 100% get processed. So that's how SQS is very good when you talk about processing high payload or high kinds of message stuff, right? So that's about auto scaling. That's about SQS, simple queuing service. This is simple notification services. Now, as you can see in the architecture, notification, I mean, this is for sending any sorts of notification. The notification can be anything. Someone upload your file to S3 bucket, someone delete an EC2 instance, something goes wrong in terms of security. You can use this notification and you can send it across two different kinds of high level user. One, users is the broad Amazon services itself. Second, some form of persons, application to person. So as you can see, these are all the AWS services. You can send it to SQS, Lambda, any EC2 instance like an API, Kinesis Firehose, and you can store in database, you can Elasticsearch and other kinds of stuff you can build. Or you can send in form of an email, mobile push, text message, those kinds of stuff you can do. Most of the people, I've also seen kind of a pattern they called as a fan out. Fan out is what they means is any message that comes from SNS. Now, SNS doesn't have any buffer. It's a very, I would say, very simple stateless service. Whatever the message it will receive, it will just broadcast. It's just simple like a broadcast service, what you have, right? Publish and subscribe. Any service which will subscribe, it will just broadcast it without storing and buffering. So now, if you want to achieve the advantage of buffering with fault tolerance and how I can do it, there exactly what people generally do is people have SNS with SQS. So the SQS provides fault tolerance, SQS provides retry, SQS provides buffering. So people fan out the SNS message to SQS, and from SQS, you can anyways by default have all those things. Like you can have Lambda, you can have auto scaling, you can send all kind of text message, push message, emails via Lambda and other services. So they fan out the notification from SNS to SQS and then consume the messages from SQS and also achieve the same use case with high availability and as well as, fault tolerant way. So that's how SNS can also work very closely with SQS in a fan out mode. The last important thing is the step function for this stuff, right? Now, so we talk about Lambda functions. We talk about Lambda functions, right, in the previous slide itself. So I mentioned Lambda function is more function as a service, but technically when you're working on the cloud, only you won't need one Lambda function, because Lambda function, as I mentioned, function as a service. So there is many functions. There can be 50 functions, there can be 20 functions, there can be even one function. What if you want to chain it? Chain it in the sense, like, for example, here you can see this flow, right? You want to have some more intelligent flow or decision at each stage that given a Lambda based on the output you want to decide where exactly you want to go. Some sort of a flow chart kind of a way of pairing or connecting or chaining this Lambda. There exactly step function comes up. Step function is more widely also recognized as an intelligent orchestration layer. And it's not just limited to Lambda anymore. You can also use this step function service for things like data flow, EMR, right? If you have any big data pipeline, you can also use step function for orchestration. If you have any machine learning, you can use step function. Even if you have any other application workflow kind of stuff requirement, you can use step function. So anywhere where you heard work like orchestration, workflow, critical, I would say chaining of Lambda or application, step function is the go-to service there, because it first of all works very closely with Lambda. This each thing, hello world question mark, or this hello world, hello, this all action, right? The behind the core action is being taken care by the Lambda itself, Lambda or direct integration with EMR or with SageMaker, along with the decision-making capability. So this things what you can see, yes, wait for 3 seconds, no, start state, end state, those all kinds of stuff you can do with step function. You can also do the same thing, like as I mentioned in SQS. I mean, you cannot buffer it for sure, like how SQS can buffer it, you cannot buffer it, but you can also do two more things is you can retry automatically without writing a code. You can design your state machine in such a way that you can retry in recursive loop. You can also get an input from external. Let's say, for example, you want to get an external input, some token or something or some approval from an end user. You can also have that kind of an external approval also in step function. That step function can take a pause, sends an approval, and someone approves, then it can continue around it. Those kinds of intelligent manual intervention also it can do, along with advanced capability of decision making here. So that's exact around the step function. Again, you don't need to go very deep part of your certifications of cloud practitioner, but this will help you to get more broader understanding how you can define or design your application. Mostly when people generally talk about this serverless application, Lambda, SQS, SNS, step function. These 4 services you will see in that architecture in any form, any shape, maybe from monitoring or notification perspective to more like an application integration or service integration. In any form, any shape, you will see all of these 4 services in that architecture. So that's what we have in our today's session. Starting from what we started, if I quickly recap, we started today with understanding what we have done, achieved in our last session about S3 storage class, transitioning the objects between storage class, Athena, what we have done. And then we moved towards finishing the Amazon S3. We moved to EC2 instance, where we understood what is EC2 instance type, families, billing model, a type of Ebs volume. And then we started our today's session where we talk about how exactly what is autoscaling, how it can help the load balancer, different types of load balancer, a quick comparison across kind of a comparison table or tabular format, how exactly each load balancer stands where in terms of functionality, which will help you to make the right selection there. And then we finish up the EC2 sections and move towards ECS, the more optimal way of leveraging the capability of EC2. VMs versus container, ECS, EKS. We went down in very detail how exactly the EKS masters and slave works. Similarly, what we have done for the ECS also in this architecture, how exactly the zoom in view look like. Then where exactly ECS and EKS stands. And the last we moved around the, the entire serverless part in the compute. Like serverless is meant for more of short running stateless computation. It's event driven, can automatically scale up, scale down. You don't have to worry about that stuff. And the pricing standpoint, you're only paying what you use. The more attractive of serverless is you just write the code, don't worry about the servers. And serverless provides you high optimization, low cost with less flexibility compared to the EC2, ECS, EKS, and bare metal. Then we understood how exactly the code execution work in case of Lambda, where and in which particular use case you should use serverless. And then we've wrapped up the entire compute section here and moved towards application integration, which is SQS, SNS, and step function. We understood that SQS sounds very simple service. And I missed one point. SQS is a very old service of Amazon. You saw that. I mean, recently we celebrated 10 years of DynamoDB. We have like 15 years of EC2 in S3. SQS is the first service of Amazon AWS. If someone doesn't know about it, SQS was the first launch even before S3. So we understood the SQS, how it looks very simple, but the kind of intelligent or kind of helpful it brings in any scalable architecture, right? Because of its buffering technique and the by default capability of retry, it can help you to design any scalable platform. Then we worked on the notification part of it, like how we can integrate your notification with SQS and design a very complex scalable platform. And at the last, we finished today's session with step function. Like if you talk about any workflow intelligent orchestration system with some more business decision making capability, then step function is the case. And that's all what we have from today's session. I'm open to any questions now. If you have any questions, please post in the chat. I'll be happy to answer them.